So friends, I wanted to answer this million-dollar question that all of you all might have today, and that's about which programming language should starters learn. And as you know, a lot of internet debate goes on here with a lot of people talking about X language versus Y language, and I think that there has to be a one-stop shop or one place where all these questions need to be answered. So this is my quick attempt to sort of get that all together in one place. And so if you are a programmer who's starting his career now, this is what you should think about, and this is how you should plan your life, and this is how you should go about dividing your time and space in programming. So first thing, let me begin by saying that programming is a tool for you to develop something. So which means that if you are using programming language, it's not something that you want to learn because you want to become an expert at that. I mean, that is kind of the byproduct of that. You become good at anything that you do. But if you learn to drive, doesn't mean that you want to end up being a driver. You essentially need programming because you want to go from point A to point B, and essentially you become a driver because you want to learn that you want to go from point A to point B. And likewise, if you have to become a programmer, that means it will help you create something. For example, Mark Zuckerberg, in his programming capabilities, he created Facebook. The Google brothers, Brian and Sergey, they created the Google search engine. So likewise, you have to create something with the skills that you have, and not get pedantic about the language that you own and what's good about it and what's not good about it and how many people use it and not use it. And I think this is important because even I am guilty of getting onto that path where I've been spending hours and hours deciding what language to learn, and I learn a particular language, I go in that particular stream, learn a few bits of it, and then I realize that, oh, this is not my cup of tea. Then I come out of it, try to learn another language. So the saga goes on, and I would really desist you from saying that don't waste your time learning several languages. And hopefully this particular presentation will help you get clarity in your journey. And if it does, I would be really happy. So that's what is the genesis of this particular presentation. So without further ado, let me jump into it. First thing is web world. So you got to decide what world you want to live in, and there are different worlds in the world of technology. So today there are the biggest one is the web world. So 70% of technologists are web developers. Let me put it, period. They might claim to be several other things, but they are not. They are simply web developers. And then there are a set of them who are closer to the machine. So they do stuff which builds your next kernel, like the Linux programming kernel, which is built by Linux Torvald. So these are guys who really go to the to the engineering depths of a particular language, and they build stuff which is not abstracted to the extent which probably a web world is. But web developers basically use that abstracted knowledge. They don't use C, but they use something on top of C, like a dynamic language, and they use that to develop programs which are then sort of used by users. So web development is the biggest consumer of programmers, and it is the biggest right now in terms of the number of people using it. And web world is the one which has really created everything around you. The Facebooks of the world, the Googles of the world, the Amazons of the world, everybody is a web development company, period. Okay. Now, apart from web, of course, now we're talking about mobile. So mobile is coming up, and that's another area. And then you also have data sciences, which is basically guys who look at all kinds of large amount of data and try to make sense out of it. And then of course there are IoT devices, Internet of Things, and devices like embedded systems which are in your cars. And if you talk about Tesla car, which is a self-driving car, and so on and so forth. So lot of spaces are there, but all those are really newer areas of development, not the the ones which are ubiquitous. So in web world, what is biggest programming language right now is called JavaScript. By no stretch of imagination can you think about any other language which is as good as JavaScript. Now, what is good about JavaScript is that it's very easy to learn. It is ubiquitous across the web. It's a dynamic language, and what dynamic means is that you can play that language around in different formats to get the same results out of that language. So it's very flexible in that sense. It is loosely typed, and this is good and bad, because loosely typed language doesn't want the user to type a lot of stuff. So for example, if you want to declare a variable in a loosely typed language, you don't have to initialize a variable. You can simply go and declare var is equal to your name, and that language will interpret that var and the name that you've given. If it is in quotes, it is a string, and if you give it a number, it is a number. But in strictly typed languages, you have to initialize that variable. You have to say that this particular variable is a number. So those things are important in strictly typed languages, but they are not important in loosely typed languages. So it's very easy. And of course, browser is your playground. What I mean by that is the browser that everybody has on their computer is an interpreter. So whatever you put into the browser is interpreted as code, and it tells you what that particular code will do. So you don't need to install any other software to see how your language is going to operate. You simply open the browser, you simply open the console, and you start using JavaScript. So that's really the biggest advantage of JavaScript. Now the not so good parts about JavaScript is that JavaScript can be really overwhelming. And what I mean by that is that JavaScript has several versions of it. JavaScript started off as a hack which was created over a period of 2 weeks. So it was trying to do some things in web which the web HTML pages couldn't do. So we called it dynamicity of the web. So it sort of alerts were created, pop-ups were created. So all that is done by JavaScript. But today the web has evolved into such a huge beast that web is all about dynamicity. So if you have a plain page, nobody would even give it any heed. They want everything to be dynamic. They want everything to be seen and moving, and they want a lot of animation. So in that sense, JavaScript has sort of cracked it because JavaScript is really good at that. So JavaScript has become bigger than HTML and CSS, which were what the web started off as. So web started off as HTML, and then CSS was added to it, and then JavaScript was added to it. But because of JavaScript's ability to interface with web directly, it became the bigger cousin, and the rest of them have really become just add-ons today. So because of that, what's happened is the web was never designed to handle so much of complexity, and right now the web world is struggling with the complexity that that JavaScript has, and thus they're doing several things, and they're creating frameworks, they're creating new versions of JavaScript. So there's so much going on that you will not know what you're doing really. You would create something and somebody else would have done it in a framework much faster than yours. There would be some other tool which will be much faster than yours. So JavaScript is really got into that magic zone to a large extent, where people deploy JavaScript to do something very quickly using a framework, and a lot of things that's going behind the scenes is not known to a lot of people. That's fine, but having said that, there is a lot going on in JavaScript. Now, talking about the JavaScript versions, there is a version called ES5 which everybody uses right now, which is going to be which is followed by ES6, which is the newest version which has come around, and then 2018 is going to see ES7, which is going to come along. So every version brings in nuances. There are different types of programming styles that you have to adopt. So it's almost like learning a new programming language. And the funny thing is that if you know ES6, then you cannot use it in ES5. You have to use something called as a pre-compiler, like a Babel. So that pre-compiler then becomes an added language skill that you need to learn, and it becomes a dependency in your overall file structure. So there are so many dependencies now to build a web page that it's really daunting, and it's very difficult for somebody to create a plain vanilla JavaScript page without having a framework to support it. And if you learn a framework, the frameworks are changing quite fast, and you need to always update yourself, and sometimes there's no backward compatibility in the frameworks. So loads of dependencies and loosely typed makes it a bane after a point in time, because it sort of lets you get into creating this huge body of code, and then we look back and try to see what's happened in the code. You would have no clue, or if somebody else sees your code, they would just go bonkers if they look at your code. And also there are too many frameworks. So there is React.js, there is Angular.js, there is Vue.js, there is Meteor.js. These are just to name a few. Every person in JavaScript now creates a framework, and then there is a fan following which goes in, and they go up to some stage and then it falls out because a new framework comes which is better and sexier than it. So I think it's kind of the dog chasing the tail. So everybody is in a wild goose chase. Everybody wants to be like a superstar of JavaScript, but there is nothing like that in JavaScript because it's evolving at such a rapid pace. Now the other area of technology is called data sciences, and here Python rules the roost. And Python is a dynamically typed language, and it's a very good programming language. It is very famous for colleges, universities, and it's also famous in the data sciences world, in the academia world, in the scientists community. So it's quite good there, but now it's transcended from that world of college kids and scientists into real world, and right now a lot of companies are using data sciences to build really smart systems which are able to interpret data in various formats and give you intelligent outputs. So in the financial technology sectors, a lot of algorithms go in determining how the stock will trend, will it go up or go down, using data analysis of that stock previously. So in that sense, it's cutting edge technology. It's really good, and data sciences has also gotten very complex these days, and there is the advent of programming which use data science libraries and statistical tools. So it's really, data sciences become like the marriage between mathematics and coding. So in that sense, it's sort of become a new paradigm where both the coders as well as mathematicians have come together to create various other forms of abstractions of data, and there are different views to that particular data, and that's now sort of almost sort of knocking on the threshold of machine learning and artificial intelligence and so on and so forth. So Python really is a cracker there. If you want to learn something which is a cracker, go and learn Python. It's very easy to learn. It's almost English-like. It's ubiquitous in the data sciences world and otherwise. It's also known in the web world, but primarily in the data sciences world. It's got a huge collection of libraries. It's been here for a long time. It was created a long time back, and it sort of has thus organically grown, and a number of libraries have been added to it. A couple of them which are really famous as NumPy and TensorFlow. It is still growing, so that's a great thing about it. Unlike a large number of programming languages who have reached the top, they're not growing anymore. And Python is not supported by or sponsored by a particular company, so it's become a language on its own, and it's really sort of come to its own, and it's platform agnostic. So it doesn't matter if you're working for Apple or Google or Facebook, all of them would use Python in some areas of their development because it's so much more ubiquitous than some language which is specific to a particular platform. There are some bad parts of Python too. So one of the biggest issues with Python is that its memory management, also known as garbage collection, is not great, and it slows the processor down because of this particular issue. So it's not as good as other compiled languages. So because it's an interpreted language, it's not very good at doing tasks in large quantities. Though it's using large data, it's not really good at processing that. So it's not really good in speeds like some of the compiled languages. And because it's sort of slow to change, due to backward compatibility issues. And this is not just an issue with Python, this is an issue with every language which has become huge. People don't want to touch it, people don't want to break the code because they don't know what's going to impact where. And that will create, loss in revenue, so nobody wants to do that. So that is not good because you can't disrupt the programming language and you can't create a new one. So that's an issue with Python. Now moving on, if you look at mobile development, there are basically three areas. There is Android, there is iOS, and there is hybrid. So Android is led by Java. So if you know Java, you are working in Android development. Android is also dominated by hybrid apps framework. So RN, which is called as React Native, and I'll cover that in detail later, is right now leading the hybrid market. And NG2, which is an offering from Angular team. So the Angular is part of the Google's umbrella, and they have developed this particular framework. So that's Android. And then if you have iOS, you might as well learn Swift, and you can learn React Native and NG2 there, because both of them can also create your iOS apps. So there is a third breed of mobile development softwares or frameworks, if you may, and those are called hybrid, and they work in both the platforms. So React Native is the #1 hybrid app development framework currently available. It is created by Facebook, and it's really modular. It's really fast. It takes the best of the both worlds. It takes some of the native abilities and marries that very nicely with some of the JavaScript availability. So it's really good for somebody who's sort of gradually moving from web development into mobile development. And likewise is Angular 2, though not as good as React Native, it's also catching up. And then there were the older gangs like PhoneGap and Cordova, which use kind of a overarching HTML and CSS and JavaScript technologies, and put together something which looked like native apps, but were not truly natives. They were hybrid. They were not really that good. So, but apparently React Native is quite close to native apps, so you don't really need to invest. If you're a development team, you don't need to invest in iOS development, Java development separately. You can simply use React Native and create an app for both iOS and Android. But having said that, you do need to remember that there are cycles for React also, so you need to develop separate Swift iOS app and separate Android app for React as well as NG2. And there are huge dependencies in running React Native in a native environment. So with that, we will move on and let's talk about some platform specific languages. So the one that I want to sort of specifically focus on is Java. And while you might be surprised when I say Java and Google, why they're synonymous. And I say this because Google has really made Java or Android as one of the most commonly used languages for mobile development. And Java is already famous in the enterprise world, so Google didn't have to do anything there. but in the mobile space it was Android which took the market by storm, and it really was one language which sort of created a huge market for Google. It's Java's legacy. It's got lots of code and lots of boilerplate. You have to write at least 10x the number of code lines in comparison to the newer languages, but it's an elephant in the room. You can't get rid of it, because if you get rid of it, half your systems will fall and break, and you don't know which might. So it's somebody you can't live without, but you have to live with as well. It's very slow to change because it has got legacy. Like I said, any legacy language has that issue. And the JVM, which is Java Virtual Machine, which is a concept of applets running in your client device, that as a concept is not necessarily going to be the future, because connectivity has reached a stage of criticality where today everything is connected, and this will only improve as we go forward. So if you sort of fast forward the world for another 10 years or 15 years, every device would be connected via internet, and the connectivity would ensure that you don't need the device to be resource hungry. You don't need to have a separate programming module sitting in your local device in your computer. So you could have really cheap devices which are large screen basically without any computing power, and those all they need is very strong internet capability, and you need an internet connection which will connect you to perhaps some server sitting in some location in some place, which will do all your computing work. So it's a paradigm shift from a thick client to a thin client, and right now the world is moving towards thin client. All the data is getting spread to locations that you would never see in your life, and you don't want to see in your life. Those locations will be managed by large companies like Amazon and Googles of the world. So that's sort of a different mindset, and Java had been catering to the previous mindset. So Java will no longer be relevant in that mindset. Now another platform which is really created waves is called Swift from Apple. It's a new kid on the block. It's supported by Apple, but it has to be backward compatible with Objective-C. So it has some of the quirks of Objective-C because it cannot get rid of all of that. And Objective-C, if you look at the world of programmers, Objective-C is not looked upon as one of the best languages to learn. So it's kind of a bane to learn it. Now Swift is more focused on depth rather than breadth. So if you learn Swift, you would learn everything about iPhones, you would learn everything about iPads, you would learn everything about Apple Watches, and if Apple is making cars in the future, then you learn that. So everything to do with Apple's platform. So if you really believe in Apple as an organization, and you don't have to think twice as far as Apple is concerned, because come on, it's the largest company in the world with a net worth of $663 billion. So a company of that size and scale will not go down the drain for the next 10 years or 15 years at least. So Swift and Apple are here to stay. Even if they don't sell a single iPhone in the next 5 years, they would stay relevant in the market. So it's a great technology to be staying off with, and in that sense it's a good language to learn. But nevertheless, you would be restricted to some of the Apple devices unless everybody else starts adopting Swift. Now moving on the platform specific space, I wanted to also cover two more platforms. One is called React.js by Facebook. So React.js was this this web development company, everybody knows about it. Facebook was a web development company that everybody knows about it. And what they realized was that the web was transcending into a different format where JS was becoming more prevalent and JavaScript was getting used everywhere. And they also realized that mobile development was also catching up. They really needed to create something which was sort of transformational, keeping um, their their web capabilities intact. So they are really a bunch of web developers who are creating web pages, and they couldn't have transformed into something as disruptive as, let's say, everybody learns Swift from tomorrow or everybody learns Java from tomorrow, because they are web development company. That would mean huge amount of disruption. So they created something which was in between that, in between native and uh, and pure play web, and React was what they created. So React JS is their answer to sort of all the issues that previous generation of JavaScript had, and addressing that, and also sort of venturing into the world of mobile development with React Native. So it's a new paradigm of programming. It is modular. It is based on huge set of libraries which Facebook has created. It uses a different syntax called JSX. It doesn't use HTML, so its entire approach to web development is not bottoms up, it's top down. So it's sort of, and when I say top down, I mean that it uses what's the most important thing in web today? It's JavaScript. But you still carry on a lot of legacy um, heavyweights dependencies, like you carry on HTML and CSS and other things which are really not necessary in today's world, because they are really just they're just text which can be added very simply into your browser, and JavaScript is the one which is basically running your browser through your DOM. So in that sense, React has been very clever, and they have used JavaScript to sort of cleverly put a new language called JSX, which sort of cleverly puts HTML codes into JavaScript and displays your web page. So that's very different and radical thinking. It's a fresh thinking, and who knows, you might just become a React JS expert and do very well in that sort of world. And it is, as I said, it's component based, it's modular, so it's pretty much plug and play. You don't break one part of your web because you removed another part of it. So that also means it's got huge set of libraries for every task, and there's a lot of magic going on behind in React, though it's not very opinionated, but still there is a lot of magic going on in React. And also because it is in the JavaScript world, which in itself is very dynamic. So JavaScript is going through this transformation of becoming the new paradigm. It's becoming the sexiest language in the web, and it's kind of becoming what it was not created to be. So everything below it also goes through that transformation. So if JavaScript is changing, then any language which is based on JavaScript has to change. So React JS is based on JavaScript. So JavaScript was using ES5, now it's moved to ES6. So React is based on ES6 rather than ES5. But a lot of computers today still use ES5 as an older version. So you have to create a pre-compiler. So long story short, it's got too many dependencies. So you can never call yourself an expert in JavaScript because there's so much to learn and there's so much going on. And then coming to the Windows world finally, which is I would just say that if you are in the Windows world, then it's okay to learn these. C# is the Windows baby, and .NET is a framework which Windows has been carrying around for a very long time. It's again an aging framework, and nothing is happening really in that space. Windows has done some work around the gaming world. So if you're into gaming, then the Unity 3D framework that they've got is good. And in mobile development, Windows has a framework called Xamarin, but Windows itself is not very big in mobile development. It's never picked on that particular market. So that's how the landscape looks like. Now, to coming to the $1,000,000 question of which programming language should you really learn, I think the question needs to be answered from your point of view as to which area would you want to go into. And once you do that, my suggestion is don't look back, just close your eyes and learn that language. Chances are that if you're in technology, you would have to learn something else. You can't stay out of a particular language. And the good part about technology is that if you learn a language, the other languages is similar. So for example, if you learn types in one language, every language has the same type. You would have a string type, you have an integer type, you'll have a floating type, you'll have a boolean type. So all the types will be similar. And if you learn a for loop, then the for loop in C# will be similar to a for loop in C, a for loop in Python, a for loop anywhere. The syntax might be a little different, but it won't take you much time to understand how it works. So the logic will be very similar. So the idea is that you use those programming concepts, you become an expert in that, you start learning those programming concepts, and then language really becomes a tool for you to create something in that space, and you can quickly transition to another language if you know something here. So if I sort of use the car analogy, it's like if you start learning one particular car, you know how to drive that car around, then the roads are going to be very different, very similar. And so if you transition from car A to car B, the second car might be automatic transmission, you must be using manual transmission, but it doesn't matter. You would learn automatic transmission in no time. The roads will always be the roads that you would use. The traffic signals will not change. Your sense of driving will not change. So you can very easily move from car A to car B. It doesn't matter which car you're going to use. So you could be using Ferrari, and you could also use a hatchback, and the basic concepts will not change. So what I mean to say is that in programming also, don't get into understanding everything about Ferrari versus a hatchback. Try to start building stuff. Go from point A to point B. Use your programming skills as a vehicle to take you from point A to point B. Don't try to learn how the dashboard works or how the lights work and what goes behind the internal combustion engine. Those are things that you should acquire as you go along in the journey. Sometimes your car will break down, then you'll figure out, oh, the carburetor is not working, and then you'll figure out, all right, the carburetor needs to get fixed, and this is what you need to do. But sometimes you don't have to worry about your carburetor because it's already been taken care of by the organization which is building the carburetor. So you don't have to worry, and you need to really think about building the car going in from point A to point B. So your focus should be really that, rather than getting worried about the language that you learn. So with that, I would come to the final thing about what you should learn, and I would go very specific here. I know a lot of people will agree with me and a lot of people will not agree with me, but what I want to convey here is that if you want to learn a particular field, if you want to go into data sciences, look no further. Python is your language, period. If you want to get into web development, look no further. JavaScript is your language. I would in fact go further and say go and learn React Native and be done with it. It will be the sort of overarching language over everything else. Don't learn anything else but React Native. Don't learn anything else but JavaScript. Don't bother learning about HTML, CSS, or any of the other things which are there. Just learn React Native and you can produce great apps. If you're in the platform space, I would say go with Swift because it sort of covers such a huge environment. If you're getting into programming, Apple is such a large company. Swift is such a new language. You don't have to worry anything about Swift because a platform comes with a set of devices where you can use it. So if you learn Swift, you can go and readily deploy that software in an Apple device, and it will be completely sort of tuned to that particular device. So you don't have to worry about this dependency or that dependency because everything will be taken care of by Apple. And that's the beauty of learning something which is supported by such a giant, because they would have created those dependencies. You don't have to worry about a particular driver or a particular software which would be needed to run that particular uh, machine. So in that sense, Swift is a great programming language. It's new, it's fresh, it sort of learns from its predecessors. Go with it. And of course, if you want to stay with mobile, then stay in the native world. I would say native is much better than hybrid world, because a lot of people might say no, hybrid is better than native, and this debate is going all along and all around. But eventually, let me tell you that even if you learn hybrid, there is no getting away from the fact that you have to create specific codes for iPhone, you have to create specific codes for Android. You have to do that anyways. You cannot you cannot be out of that jungle. You have to be in that jungle. So and the market is so fragmented in the mobile world. You have a zillion viewports of a mobile phone. So what I mean by viewport is the size of the mobile device. So you got smaller devices, you got larger devices, and sometimes that's very confusing. So you might create a software which is tuned to a 6-inch mobile phone, and suddenly you'll have a 6.5-inch mobile phone, and you'll have to rewrite the code. And with some of the newer frameworks, that's not a problem. For example, React Native, that's not a problem. But then again, React Native will be resource hungry, so it will not be as efficient as a native app if you are developing it for a mobile company. But if you use, let's say, native app, if you use Java for Android development, or you use Swift for iOS development, then it will be far more resource efficient. It would be pretty much plug and play for you, and you would stay in the world. And I think the most important thing is not anything else, but the fact is that you will remain sane. You will not get inundated with so much that's going on. So if you personally ask me, I have an iPhone, and I have been very happy with the fact that I have switched into iPhone. I don't have to really worry about changing my phone every 6 months. I don't have to worry about new softwares which are getting launched. I don't have to download them and install them. Apple does everything for me. It automatically gets downloaded, it automatically gets installed, and I don't have to do anything, and it does everything in such a seamless manner that I go and sleep, and the next morning I've got a new software updated. So that takes away the pain of and this is just one factor that I've realized, that it sort of takes away the pain of having several things around you. So you could, in an analogy, you could have 10 cars, but eventually you'll be running only one car. You could have 10 bank accounts, but eventually you'll be using only one bank account for most of the things. So the question really is, what do you want to do with that particular piece? And if you want to stay in a particular tool, then just use that tool. And you don't have to use a tool which is not being used by everybody else. So I'm not saying that go and use a mobile device nobody uses. Stay in Java. If you like Android, use Java. If you want to stay in iOS, use Swift. Nobody's stopping that. But the point of it I'm trying to convey is that stay focused on a particular space, and you will really reap the benefits of that over a period of time, rather than switching from Android to iOS to web to data sciences and so on and so forth. Because the very fact that you're in technology means that you know what's going on. So that itself is a great thing. So don't worry about too many things. And with that, I would sort of try to end this PPT. I know it's been a really long drawn PPT, but I wanted it to be a one-stop shop, and I wanted everybody to sort of get a sense of what the technology world looks like. And there's a lot more to cover. I've not covered the world of IoT. I've not covered the world of neural networks or artificial intelligence. Those are another big animals. But I just wanted to cover it from a programmer's point of view. So when you try to learn any of these 4 languages or these 3 languages, chances are that you would automatically get into something which would take you to a particular path, and that path will open up a whole host of opportunities. So you can't go wrong with these technologies. So I really hope you do well in your programming career, and I want to give you a double thumbs up and just double down on a particular technology. Don't worry about anything else and start coding. So happy coding and have a great day.